All right, let's dive into something that honestly touches almost every Ruby on Rails developer's daily grind. Wrestling with our views. Specifically, working with HTML and ERB files. We've got some fascinating source material to unpack today. It's all based on a presentation by Marco Roth at Ruby Kaigi.
Right, Marco's talk.
Yeah, introducing a really promising initiative called ERB. So our mission here, to really understand the long-standing challenges of building good tooling around these files and see how ERB is stepping up, trying to dramatically improve that experience.
That's exactly it. Marco's talk, it really zeroes in on a gap that I think many of us have felt pretty keenly in the Ruby tooling ecosystem.
Yeah.
We've seen incredible advancements in tooling for Ruby code itself over the years, but the view layer, where Ruby gets deeply tangled up with HTML, that's often felt a bit like the Wild West.
Definitely.
And this Project ERB, it's about way more than just better syntax coloring. It's about getting a deep structural understanding of these files to enable truly intelligent developer tools.
Okay, let's maybe step back a bit then. Before we dig into ERB itself,
Yeah.
can you walk us through a bit of the recent history, like where has Ruby developer tooling, especially inside our code editors, come from?
Sure, yeah. As the source material lays out, for quite a while, editor support for Ruby was, well, pretty basic.
Right, syntax highlighting maybe?
Exactly. You had syntax highlighting, maybe some simple word completion. But things started changing significantly around 2008 with RubyMine.
RubyMine. Yeah.
Which brought a whole suite of more advanced features, much smarter auto-completion, code navigation, project indexing, that kind of thing.
So editors basically had to build their own Ruby brain inside them.
Pretty much, yeah. Each editor, or IDE in RubyMine's case, was building its own specific support. And that was the way things were for quite a while.
Okay.
Then, in 2016, Microsoft introduced the Language Server Protocol, LSP.
Right, LSP. That was a big deal.
Huge deal. The core idea was, frankly, brilliant. Decouple the language smarts from the editor itself. You write one language server for Ruby, say, and any editor that understands LSP can talk to it. And suddenly they all get the rich features, diagnostics, hover info, go to definition, refactoring, everything.
Containerized the whole thing. Saved a ton of duplicated work.
Exactly, a massive improvement.
And did Ruby get on board with LSP fairly quickly?
Yeah, reasonably so. The first Ruby LSP implementation, Solaraf, popped up in 2017.
Yeah.
It basically proved that, yes, you can build an LSP even for a dynamic language like Ruby. We saw LSTs emerge for different languages and frameworks. But the really big leap forward for the general Ruby LSP experience probably came in 2022, the Shopify Ruby LSP. That one really pushed the boundaries of what people thought was possible, much more comprehensive.
Now, the source also mentioned looking sort of outside the Ruby bubble, specifically at JavaScript.
Yeah, that was definitely a key inspiration highlighted in the presentation. You look at the JavaScript world, and the tooling for modern frameworks often feels incredibly sophisticated. So the question became, could we bring a similar level of experience to Ruby, especially in those areas where Ruby meets the front end?
Makes sense.
And this led to some earlier, more focused efforts within the Ruby community, specifically targeting the Hotwire ecosystem.
Okay, Stimulus and Turbo.
Exactly, resulting in the Stimulus LSP and the Turbo LSP.
And those were helpful. Did they solve some problems?
Oh, absolutely. They were a definite step forward. They provided really valuable features, especially around working with those HTML attributes that Hotwire uses heavily.
Like data controller and data action.
Right, stuff like that. They could analyze both your JavaScript files and your HTML or ERB to offer auto-completion and diagnostics for those specific attributes. Really useful.
I sense a but coming.
There is a but. A pretty fundamental one, actually. And it's the crucial limitation that ERB is designed to solve.
Okay.
As the source points out, those earlier LSPs, they were essentially HTML only in how they looked at the view files, meaning they understood static HTML perfectly fine. But the second they hit an ERB tag, like % or %, they basically treated it as a black box, an opaque blob. They processed the HTML around it, but they couldn't see or understand anything happening inside that ERB block, or even the HTML that might be generated by the Ruby code inside it.
Okay, so if I'm using standard Rails helpers like tag.div to make a div, or passing a Ruby hash for data attributes.
Exactly. To those tools, that was just a chunk of Ruby inside %, or %. They couldn't parse it, couldn't figure out that it was actually generating HTML.
So no help there.
None. No errors, no diagnostics, no auto-completion, nothing for anything happening within or produced by those dynamic Ruby parts, which, is a huge blind spot in files that are specifically designed to mix the two.
Yeah, that's kind of the whole point of ERB. And thinking about today's Rails world, this limitation feels even bigger now, right?
Absolutely. As the source highlights, one of the big shifts with Rails 7 was making Hotwire Stimulus and Turbo the default front-end approach, which really solidified this pattern where many Rails apps rely heavily on server-rendered HTML with interactivity triggered by those HTML attributes.
And the data backs this up. People are actually using it.
They are. The Rails developer survey results mentioned in the talk are pretty telling. Stimulus usage, for instance, jumped significantly, reaching about 31% adoption last year.
Wow.
And it's not just a Rails thing either. If you look at the wider ecosystem, like the State of JS survey, you see similar philosophies gaining traction, things like Alpine.js, which is a bit like Stimulus, and HTMX, which has parallels to Turbo. They're growing too.
Okay.
So this broader move towards HTML-centric, server-driven approaches really underlines why having solid tooling for this view layer is so important now.
So Hotwire is default.
Yeah.
Hotwire lives in ERB views. Therefore, better tooling for ERB views isn't just a nice to have, it's kind of essential for a good modern Rails dev experience.
Precisely. The view layer is where so much of the application logic now meets the user interface. You really need smart tools to help manage that complexity.
Okay, so we need tools that get HTML and ERB together, but the talk made it clear this isn't easy. Why is adding ERB support so tricky?
Well, the core problem is ERB's flexibility. ERB isn't just for HTML, right?
Right, you use it for YAML, text, emails.
Exactly. So a generic ERB parser doesn't inherently know anything about HTML rules or structure. This project, ERB, is specifically focused on the HTML ERB case, Ruby embedded within an HTML document structure.
And the first idea was to use existing tools.
Right. The natural first thought was, hey, can we just leverage the great parsers we already have?
Like NoCoGi for HTML, Prism for Ruby.
Exactly. The idea was take an ERB file, somehow split it into HTML bits and Ruby bits, feed the HTML parts to NoCoGiri, feed the Ruby parts to Prism, job done.
Sounds plausible. What went wrong?
Well, several critical problems cropped up, as Marco detailed. The biggest one was just loss of context.
How so?
When you parse the HTML and Ruby submits separately, you totally lose the vital information about their relationship, their position within the original file. Where exactly was that ERB tag?
Ah, like was it inside a paragraph tag?
Yeah.
Or spitting out an attribute value?
Precisely. Was it generating text? An attribute? Was it part of an if statement? That context is everything.
And why does knowing where it is matter so much?
It matters for almost any advanced tooling you can think of. Security linters, for example. They need to know if you're injecting dynamic content directly into an attribute value to spot potential cross-site scripting risks, XSS.
Okay.
Autocompletion needs to know if you're typing inside an attribute or just plain text. Refactoring tools need to understand the whole mix structure. You lose that, you lose the ability to build smart features. And there was another technical hurdle, too. Standard HTML parsers like NoCoGiri, they're great for building a DOM, but they didn't always give precise location info for every single node relative to the original source file.
Making it hard to put the pieces back together accurately.
Extremely hard. Trying to stitch the HTML and Ruby parse results back into a single usable picture of the original file was proving really difficult. Plus, standard parsers are often built to be forgiving. Like, a browser's HTML parser tries its best to render something, even if the HTML is broken.
Right.
But for developer tooling, you need to analyze exactly what the developer wrote errors, and all to give useful feedback. Splitting the file and using parsers that might try to fix things or ignore errors, it just wasn't capturing that essential source truth.
So gluing together results from tools that didn't understand the original mix or weren't really designed for source analysis, that wasn't going to work for building truly smart tooling.
Exactly. It became pretty clear that a fundamentally different approach was needed, one that could parse the HTML and the ERB as a single integrated thing.
And this is where ERB comes in properly.
This is where ERB comes in, Marco Roth's solution. Build a custom parser specifically for this exact problem. Build it from scratch, and hence the name ERB, HTML and ERB, capturing that core purpose.
Building a parser from scratch.
Yeah.
That sounds like a pretty major undertaking.
It definitely is. But, the source material makes a strong case that the existing tools just didn't meet the specific needs for deep tooling analysis.
Right.
So ERB is designed following principles similar to Prism, the new Ruby parser. It's written in pure C99.
C9.
Yeah, keeps it lean. Its only external dependency is Prism itself, which it uses specifically to parse the Ruby code found inside the ERB tags.
And why C portability?
Portability was a huge driver, yeah. Writing it in C means ERB can be easily used from different languages and environments. They already have bindings for Ruby, naturally.
The GEMRB you mentioned.
Right. And also for JavaScript TypeScript via NPM packages. And they even have a WebAssembly build.
So it can run in the browser too. Cool.
Exactly. Runs right in the browser. Beyond portability, the design goals were error tolerance, absolutely critical for tooling, dealing with code in progress, and maintainability.
You mentioned it has a custom HTML extern parser inside it. How's that different from, say, Nokogiri or what a browser uses?
Yeah, this is one of the really key innovations highlighted. A standard HTML parser, its job is usually to build a correct document object model, a DOM tree. It often implicitly fixes errors or rearranges nodes based on HTML specs to achieve that.
Okay.
ERB's custom parser, though, is built for tooling. Its main goal is to represent the source file exactly as the developer wrote it. It preserves the original structure, whitespace, and crucially, it captures syntax errors or incomplete tags without trying to fix them.
Got an example?
Yeah, the presentation shows an opening H1 tag that's just missing its closing tag. ERB's parser doesn't guess or try to complete it. It correctly identifies the open tag, records that the close tag is missing as an error, and sets the clause tag node to null in the syntax tree it produces.
Whereas a browser parser might just assume it closes later or something.
Exactly. ERB gives you the messy reality of the source code accurately, not some cleaned-up interpretation.
So it captures that source truth, errors included, and outputs a single integrated syntax tree showing how the HTML and ERB nodes fit together.
Precisely. That integrated tree is the foundation.
Okay, so as a developer, if I want to play with this parser part right now, how do I do it?
The core parser is out there. You can add gem ERB to your gem file in a Rails app. Or if you're doing JavaScript tooling, you can grab the packages from NPM.
Including the WebAssembly one for the browser.
Right. And both offer a consistent API. You can lex the source into tokens, parse it into that syntax tree, and even extract just the Ruby or HTML parts if you need to.
Can you give us a super simple example of what that parse tree output looks like?
Sure. Based on the examples shown, like an empty file just gives you a root document node. Simple.
Okay.
Add some plain text like hello world, and the document node gets an HTML text node child containing hello world.
Makes sense.
Add a complete HTML element, say div a div. Now the tree shows an element node for the div. That node has children. One for the open tag, div, one for the text content, and one for the close tag.
And nested elements?
Just appear as nested element nodes in the tree. It directly mirrors the HTML structure you wrote.
Got it. And the ERB tags themselves, like %user.name%.
That gets represented as an ERB content node, and this node holds specific info. The type of tag, % in this case, the actual Ruby source code inside, user.name, the closing tag token, %, and really importantly, its exact location in the file. It can even tell you if the Ruby code inside is valid according to Prism.
Okay, but views get more complex. We use control flow all the time if each end. How does ERB handle that structure, especially when HTML is mixed inside?
Yeah, this is where a clever two-step process comes in. First, the initial parse identifies each individual ERB tag. So you might get an %, if condition %, then maybe some HTML, then maybe another ERB tag, and finally an ampersand %n%. Initially, these are just separate ERB content nodes.
Okay, so a flat list initially.
Sort of, yeah. Then ERB does a second pass over this initial tree. It looks specifically for patterns that signal control flow blocks. It sees an if tag, and then it gathers up all the nodes that follow it until it finds the matching end tag.
And it reorganizes them.
Exactly. It transforms those separate nodes into a single logical ERB if node. This new parent ERB if node then contains all the nodes that were originally between the if and end tags as its children.
So it understands the nesting. If I had an H1 tag inside that if block.
Then the final tree will show the ERB if node containing the H1 element node as one of its children.
Perfect. That models the actual structure, the HTML's existence is conditional on the Ruby logic.
Exactly. And it's that structural understanding that lets you build really powerful tools on top. It's not just guessing anymore. And ERB also handles attributes, doc types, comments, and does a good job with whitespace, which can be tricky. It recognizes common Ruby control flow like case, begin and represents them with specific node types, similar to how Prism does for pure Ruby.
Okay, that's a really solid parser foundation. So now let's talk about the tools being built using this detailed, accurate tree. What's the first wave of stuff we're likely to see?
Right, the parser is step one. Based on the source, the immediate goals are focused on building out the ERB toolkit, primarily a formatter and a linter.
An auto formatter for HTML ERB, like Prettier or Rubocops formatter, but specifically for these view files.
That's exactly the idea. You give it your messy, inconsistently indented HTML ERB code, and it spits back nicely formatted code according to a set of rules.
Nice.
And one really interesting aspect mentioned is that because the parser and maybe the formatter itself could be built purely in C and exposed via WSMA or other bindings,
It might not need a full Ruby environment to run.
potentially, yeah. That could make it super fast and really easy to drop into pre-commit hooks, CI pipelines, or directly into editors without waiting for Ruby to boot.
That would be slick. Okay, and the linter. What kind of checks can that do now that it understands the structure?
So the linter runs validation rules after parsing. Because ERB's custom parser gives it that exact source structure, errors and all, the linter can analyze the tree for all sorts of issues.
Yes.
Standard HTML5 validity rules are tags nested correctly, are required attributes there, like alt on an MG tag. And really importantly, because it knows where the ERB nodes are and what kind of context they're in, like an attribute value, it can perform checks for potentially unsafe interpolation.
Looking for those XSS vulnerabilities again.
Exactly. Flagging places where dynamic Ruby output is being jammed into sensitive HTML contexts. And the idea is for this to potentially integrate with existing tools like Rubocop, too.
Okay, those sound like really practical, useful tools right off the bat. What about the longer-term, more visionary stuff hinted at in the talk?
Yeah, this is where it's really interesting, potentially moving beyond just developer tools and influencing how views are rendered. The source mentions a concept codenamed reaction view.
Reaction view. Okay, tell me more. Sounds reactive.
Think of it as a potential enhancement for Action View, Rails' standard view rendering system. It's inspired by things like Phoenix Live View. The core idea is this. If you have a smarter rendering engine, powered by ERB's deep understanding of the ERB template structure, it could figure out exactly which parts of the final HTML output depend on which specific application state variables.
So it knows this bit of HTML comes from @items, and that bit comes from @user.
Something like that, yeah. And the benefit. Efficiency and interactivity. Let's say the engine knows that a list of items in your HTML template only depends on the @items array.
Right.
If @items changes, maybe you add a new item, the engine wouldn't need to re-render the entire page. It could use the ERB tree to pinpoint only the part of the template related to displaying those items, re-render just that small piece, calculate the minimal difference, the diff between the old HTML and the new HTML for just that section, and send only that tiny diff over the wire to the client.
For super efficient UI updates driven from the server.
Exactly. Potentially bringing live view style capabilities to standard ERB templates just by understanding their structure really well.
Wow, okay. That's ambitious.
Yeah.
And there's another big idea too, right? Something about a unified tree.
Yes, this one tackles the fragmentation we have in Ruby templating languages.
Yeah.
Right now, ERB is focused on ERB and HTML.
But we also have HAML, Slim.
Exactly. AML Slim, maybe others. Each has its own syntax, its own parser, and often completely separate tooling efforts, which means duplicated work, inconsistent features.
Right. So the unified tree idea.
The grander vision is to create a standardized parse result structure, a common syntax tree format that could represent any HTML templating language in the Ruby world.
Okay.
ERB already produces such a tree for ERB, and importantly, it's designed so it can represent action view helpers like linkto or content tag as their underlying HTML structure within that tree. The big idea is, let's build parsers for HAML and Slim that also output the same shared standardized tree format.
Why go to that effort? What's the payoff?
Massive tool unification. If you can translate HAML, Slim, and ERB into this common tree format, then all the advanced tooling built on top of that tree.
The formatter, the linter, LSPs, static analysis.
Even maybe that reaction view engine can all be built once to operate on the shared tree.
So the ERB formatter could format HAML or Slim. The ERB linter could check HAML or Slim for XSS.
Exactly. You write the tool once, and it works across different templating syntaxes. It unifies the development effort for tooling and could drastically improve the quality and availability of tools across the whole Ruby templating landscape.
That is a powerful concept.
Yeah.
Using the parser work as a foundation to lift all boats, no matter which template language you prefer.
It's about building that foundational language-agnostic infrastructure for the view layer. Pretty exciting stuff.
Okay, let's bring it back down to earth for a sec.
Mm.
Near term, what are the immediate next steps we might see for the ERB project itself?
Well, the short-term focus, as laid out, is definitely getting that formatter and linter stable and shipped. Those are actively being worked on. Then, integrating the ERB parser into existing and future tools is crucial. That means enhancing the Stimulus LSP and Turbo LSP with this deeper understanding of the mixed HTML ERB structure.
So they stop seeing ERB as a black box.
Right. And potentially creating a direct Ruby LSP extension or integration just for ERB files. The goal is to use that accurate parse tree from ERB to enable much smarter diagnostics, code actions, refactoring, all right in your editor specifically for views. They're also working on better support for recognizing action view helpers, so tools understand that linkto generates a tag, for instance. And multi-file analysis is on the roadmap too, understanding how partials fit together, maybe finding unused one.
And for folks listening who are curious and want to poke at the parser right now.
Yeah, the interactive browser playground at erb.tools playground is the place to go.
Erb.tools playground.
Okay, you can paste your own ERB code in there and see the syntax tree it generates live in your browser. It's a great way to understand how it represents different structures, errors, control flow, and how the location mapping works. Really helpful for getting a feel for it.
It really does sound like ERB is set up to be a foundational piece for view layer tooling in Ruby, kind of like Prism is becoming for general Ruby code analysis.
That's definitely the hope, and I think it's a fair comparison. Prism, which is shipping with Ruby 3.4 now, is already having a big impact on everything from language internals to developer tools. ERB has that same potential for a foundational impact on how we build and maintain the view layer.
Yeah.
It feels like part of this broader push in the community to bring the same level of care, sophistication, and tooling quality we see elsewhere in the Ruby stack right to the place where our apps meet the user.
So ERB offers a really concrete path forward, a way to significantly improve the developer experience when we're working in views in Ruby and Rails, making that core part of the job much more productive, maybe even more enjoyable.
That's the ultimate goal, yeah. Making the view layer feel like a first-class citizen for tooling, not some tricky afterthought.
Well, that brings us towards the end of this deep dive into ERB. We've gone from the history of Ruby tooling challenges and views, dug into the design of this powerful new parser, looked at the immediate tools like the formatter and linter, and even gazed into the future with reaction view and that unified templating tree idea. Pretty cool journey.
Absolutely. And maybe as you, the listener, are thinking about all this, here's a final thought to chew on. How might having tools that truly understand the intricate, mixed structure of your HTML and ERB views actually change the way you approach building user interfaces in Ruby on Rails? Could knowing the deep details of your templates, the subtle ways Ruby and HTML interact, unlock new patterns, new optimizations, or maybe even entirely new ways of thinking about front-end architecture in your own apps? If you're intrigued, definitely check out the ERB project.